Hello everybody, my name is Ananya Shukla and today I am going to tell you about what is functional dependency and we'll solve examples of functional dependencies as well. So what is functional dependency? Functional dependency actually is a relationship between attributes of a table. So if A tends to B, then A is functionally dependent on B. So we can derive the value of A using the value of B. So actually functional dependencies are used for normalization and designing the schema of the table, and it ensures data redundancy and data integrity as well. So now we'll move forward. Types of functional dependencies. So there are various types of functional dependencies, in which first is trivial functional dependencies, which means if A is derived by B, then B is a subset of A. So if B is a subset of A, so if we see over here, there is no sense of this functional dependencies in actual practice, as if we derive A is derived by B and B is a subset of A, so we already know the value of A for which we are finding it in B, so there is no sense. So for non-trivial functional dependency, if A tends to B, then B is not a subset of A. So this is non-trivial functional dependencies which we usually use. And transitive functional dependency means that if A tends to B and B tends to C, then A tends to C as well. And if we want to know about fully functional dependency, it means if B is fully functionally dependent on A, then there is no subset of each other. Then we'll just go to next slide. Here it is Armstrong's axioms. So in Armstrong's axiom, we'll just get to know the set of rules which every functional dependencies needs to follow. So it first follows reflexivity, which means if B is a subset of A, then A tends to B. And then augmentation as well. Augmentation means if we add a specific attribute to both sides of left and right side of the functional dependencies, then nothing changes. So here we can see if A tends to B and then we add C to both sides, there is no change in it. It still derives AC from BC. Then transitivity means if A derives B and B derives C, then A derives C as well. Then we'll see what is union. So union means if A derives B and A derives C as well, then A will derive B and C together. Decomposition means if A is derived by B and C both, then we can just derive A by B and A by C independently. Now we'll move forward. Computing closures. So using functional dependencies, we can actually compute closure of a attribute. So here we'll just here we have given a functional dependency, A tends to B and B tends to C, so for which we'll find the closure. So here we'll first find the closure of A. So step 1, we'll find the closure of A will have its own value in its closure, as we can derive A from A. Then step 2, A can be derived by B, so we'll add B as well in its closure, and then B can derive C, so here we can add C also in A's closure. So the closure of A will be A, B and C. Now similarly we can find the closure of B and C as well. So in closure of B will be there itself and C will also be there, because B can derive C. So, and if we will see to the closure of C, there will only be C in it, because we cannot derive anything by C over here. Now we'll move forward. So finding candidate keys. So we'll know how to find candidate key. So we will just first see what is candidate key. Minimal set of attributes that determine all the other attributes in the relationship table is known as candidate key. So we use closure to actually check whether the key attribute is a primary key or candidate key or not. So first we will find the closure of A and all the other attributes which are in the relationship table. So we'll find the combinations to find the minimal number of candidate key. For example, if we have a relation A, B and C, so we'll first find the closure of A, then the closure of B and then closure of C, and we'll just check which of the following are eligible for candidate key. So here the functional dependencies are A tends to B and B tends to C. So if A tends to B and B tends to C, so A can derive B and C as well, and it always derives itself. So the closure of A is ABC, hence we can say A is a candidate key over here. Now we'll see in this relation A, B, C, D. Functional dependencies are A tends to B, B tends to C, and C tends to D. So if we'll find the closure of A, we will see that the closure of A is A, B, C, D, because A can derive B, and then B can derive C, and then C can derive D. So here A is the candidate key. We can just find the closure of B as well and C as well, but there is no sense of finding it as we have already got to know what is the candidate key of the relationship. Now we'll move forward. And in an example, so here we have a relation in which the attributes are A, B, C, D. Functional dependencies is A tends to B, B tends to C, and C tends to D. So if we want to compute A closure to find if A is a candidate key or not, so A tends to B, so A can derive itself and A can derive B as well. So after that B can derive C, so we can include C as well in our closure set of A. Then C can derive D. So you can derive D. So A, B, C, D all will be there in the closure of A. Hence A is a candidate key. Thank you. And then exercise number 2. Well, example number 2. So in this we'll actually find out the candidate key of the relationship A, B, C, where functional dependencies are A, B, C. A, B tends to C and A tends to B. So now the closure of A will be A tends to B. So A will be in the A closures, B will be also there in A closure. Now then if we have AB in the closure, so AB can derive C, so C will also be in A's closure. So if A, B, C are there in A's closure, then A will be the candidate key, since all attribute can be derived by A. Now AB can also be a eligible candidate key, but we already have initially find out that A will be the candidate key, so AB will be a super key instead of candidate key, as we only take minimal subset of attributes as a candidate key. Now conclusion. Using functional dependencies, we can actually express a relationship between attributes. We can also determine the closure of the we can also determine the closure of the attributes, which helps in determining the candidate keys. We can also actually find the schema designing of the database, and we can also find the functional normalization using functional dependencies, as it is a basic part of finding the normalization of a database. Actually, normalizing a database, the foundation for it is functional dependencies. So that's the end, and I hope you liked the video. Thank you for watching.